So we want to approximate the value of the square root of 50 without a calculator. How does that have anything to do with what we just talked about? Okay, we had a function, right? What kind of function do you think we might use to do a problem like this? Okay, I like that. So let's just say, to start with, that f of x is equal to the square root of x. And we don't really need it, but I'll draw a picture of the function. I think we have a pretty good idea of what the square root function looks like. So that's going to look like this, right? And I'm going to scale it so that we get the points that we need here. So let's go all the way out to, what do you say? What should we put there? 15? No, I'm sorry, not 15. On the x-axis, well, we need to get 150 somewhere on there, but I want to go beyond that. 200? Okay. 200 is good, except I don't know what the square root of 200 is, so I don't know what the value of the point is going to be there. Maybe 225. What do you think about that? Do you guys see why I want to use 225? Because I know what the square root of 225 is. So the point here at 225 is going to be what? 225 comma 15. Okay. And we want to know what the value of this function is at 150, which is going to be, I don't know, somewhere in here. Doesn't really matter exactly where it is. So we want to know what the value of the function is at 150. What could I do? Okay, so we know the square root of 144 is 12. That's a really good start. So 144 is going to be really close to that, and we know the value of that is going to be 12. Which means the square root of 50 is going to be a little bit bigger than 12, right? Well, let's be a little bit more accurate, though. We don't want to be just a little bit bigger, but we want to know how much bigger. So what do we want to do? What is the linearization going to look like? I don't really care what it is right now. What's it going to look like?
A line.
Okay, there's going to be a line. Is it that line? No. Okay, the tangent line. Is it going to be the tangent line here? Or here? Or here? Or here? Where? Not at 150. Here's the thing. We want to approximate the value at 150, but we don't know what the value at 150 is. So if we don't know what the value of the function is at 150, then we can't really write the equation of the tangent line, right? So if we want to write the equation of the tangent line, we need to know what the y value is also. So where do I know what the y value is?
144.
At 144, right? So I'm going to, I want to look at the tangent line through the point 144.12. Let me move that just a little bit here. Oops. Now, I wish I could zoom in here for you guys. But you can kind of see that this point here that we're looking for the value of, the y value of, is essentially on that tangent line, isn't it? So what we're going to do to approximate the square root of 150 is we're going to figure out what the value of the line is at 150 rather than the value of the square root function. Does that make sense? Okay, now we had that formula. We could use the formula, or you could just use the tangent line. Let's go ahead and use the formula for this example, and then for the next example we'll use the tangent line. So the linearization L of x is going to equal what? What are we going to put in for A? 144. So it's going to be f of 144, which is 12. Plus the derivative of the function at 144, And does anybody know what the derivative of the function at 144 is? What are we probably going to have to do? Take the derivative, yeah. So the derivative of the square root function, remember that is x to the 1/2. So the derivative is going to be 1/2 times x to the negative 1/2, which would be 1 over 2 square root of x. You guys okay with that? Do I need to explain that in a little more depth, or are you go okay with that? Okay. I'm going to kind of assume from here on out that you know how to take the derivatives at least. So what is the derivative then at 144 going to be?
124.
Yeah, it's going to be 1 over 2 times the square root of 144, or 1 over 24, times x minus 144. Now, this actually will give us the value of any point on the green tangent line here, but I want to know specifically what the value is at 150. So what do I do to do that?
Plug in 150 for x.
Thank you. Plug in 150 for x. So the linearization at 150, which is going to give us approximately what the square root of 150 is going to be 12 plus 1 over 24 times 150 minus 144. 150 minus 144 is 6. 6 over 24 is a fourth, right? So it would be 0.25. So it's going to be approximately equal to, the linearization is going to be equal to 12.25, which means then that the square root of 150 is approximately equal to 12.25. What do you think about that? Pretty easy? Okay, so then the second part here says use your calculator to check the accuracy of your answer. I see at least one person doing that already. What's your calculator say?
12.2474.
How do we do? It's pretty close, isn't it? So rather than saying the square root of 150 is just a little bit bigger than 12, we can say pretty close to exactly how much bigger than 12. It's accurate to 2 decimal places. If you round to 2 decimal places, it's 12.25. So that gives us a pretty accurate answer without having to use the calculator. Now, like I said, the calculator would give you the answer fairly accurately, fairly quickly, very accurately, fairly quickly. But you can see why this would be useful before calculators were readily available, right? Like back in the 60s before you had a handheld calculator.